defining what an absolute value function is. The absolute value operation takes anything plugged into it and makes it positive. We've seen before the absolute value of 5 equals 5, and the absolute value of negative 5 equals 5 as well. An absolute value function is actually a piecewise defined function. It's f of x equals negative x for x less than 0. So if x is negative, we're going to change the sign. A negative negative becomes a positive. And f of x equals x for x is greater than or equal to 0. The graph of an absolute value function would look like this. It would decrease until it hits the origin, then it would increase. These are basically a mirror image of each other. An absolute value equation can always be broken down to something like this. If k is a positive integer, then the equation, the absolute value of ax plus b, close our absolute value equals k, has two possible solutions. Either ax plus b equals k, or ax plus b equals negative k. The reason this occurs is we do not know if the stuff inside the parentheses, inside the absolute value, is a positive k or a negative k. And it doesn't really matter because the absolute value will make it positive in the end, but we have to solve for both. Now when you go to solve absolute value equations, we need to get the absolute value isolated by itself first, and we'll see an example of that in a second. Let's solve the absolute value of 2x minus 8 equals 14. Notice the absolute value is on the left-hand side by itself. So I can go ahead and start and break this into two equations. My first equation is 2x minus 8 equals 14. My second equation is 2x minus 8 equals negative 14. I'm going to solve both of these separately. 2x minus 8 equals 14 tells me 2x is 22 by adding 8 to both sides. Divide both sides by 2, I get x is 11. Or I have a situation where 2x minus 8 equals negative 14. Add 8 to both sides, you get 2x equals negative 6, x equals negative 3. Well, let's see how this works. If x is 11, 2 times 11 is 22, minus 8 is 14, absolute value of 14 is 14. If I plug in the other one, negative 3, 2 times negative 3 is negative 6, negative 6 minus 8 is negative 14, and the absolute value of negative 14 is 14. Hence, pretty much every time you're dealing with an absolute value, you're going to wind up with two equations. Here's an example where you have to manipulate things first. It's 3 times the absolute value of 5 minus 8x, close my absolute value, minus 9, equals 6. To set these up, I need to isolate the absolute value first. So let's add 9 to both sides. We get 3 times the absolute value of 5 minus 8x equals 15. Divide both sides by 3, I get absolute value of 5 minus 8x equals 15. Now I can set up my two equations, either 5 minus 8x equals 5, or 5 minus 8x equals negative 5. If 5 minus 8x equals 5, then negative 8x is 0, so x is 0. Or if 5 minus 8x equals negative 5, then negative 8x is negative 10, so x is 5/4. There are situations where you have two absolute values equal to each other, and this is really not that difficult to undertake. If I have the absolute value of 4x minus 8 equals the absolute value of 3 minus 2x, one situation is I drop both absolute values, I get 4x minus 8 equals 3 minus 2x. The other situation is I drop the absolute values and make one side negative. So 4x minus 8 equals negative times 3 minus 2x. We were to solve the left one first. 4x minus 8 equals 3 minus 2x. Add 2x to both sides. Add 8 to both sides. You get 6x is 11, where x is 11/6. If I distribute this negative sign over here, you get 4x minus 8. Your right-hand side, when I distribute the negative, is negative 3 plus 2x. Subtract 2x from both sides. Add 5 to both sides. You get 2x is 5, so x is 5/2. And again, you can plug this in easily and find out you get the same answers on both sides. Solving absolute value inequalities. If I have some number greater than 0, some positive number, when I'm dealing with less than, if I have ax plus b, the absolute value of ax plus b is less than k, this is equivalent to an interval, negative k less than ax plus b less than k. This also works with less than or equal to. If I have greater than, if I have the absolute value of ax plus b is greater than k, this is equivalent to ax plus b is greater than k, or ax plus b is less than negative k. Let's see how this works with the less than first. If I have the absolute value of 5x minus 9 is less than 13, that means negative 13 is less than 5x minus 9, which is less than 13. I now have three sides. I have to do the same thing to each side. When I add 9 to every side, you have negative 4, less than 5x, less than 22. Divide everything by 5, you have negative 4 fifths, less than x, less than 22 over 5. These are my two endpoints of my interval. So my interval is from negative 4 fifths to 22 fifths, open parentheses on both sides. Here's the corresponding graph of these. Notice the open interval is shown on the graph as well. The greater than is slightly different. I'd put a couple more steps in here to show you how to work these. Again, if we have a greater than or a less than, we still have to isolate the absolute value. This is 3 times the absolute value of 2x plus 1. Close my absolute value. Minus 11 is greater than negative 2. Let's add 9 to both sides. So I have 3 times the absolute value of 2x plus 1 is greater than 9. Divide everything by 3. I have the absolute value of 2x plus 1 is greater than 3. So I have two situations I have to look for. Either 2x plus 3 is greater than 2x plus 1 is greater than 3, or 2x plus 1 is less than negative 3. If 2x plus 1 is greater than 3, then 2x is greater than 2, and x is greater than 1. Or, if 2x plus 1 is less than negative 3, 2x is less than negative 4, x is less than negative 2. I have two intervals here. I have the interval negative infinity to negative 2, union 1 to infinity. In other words, my answers falls in one of these two. When I say union, it basically means or, one or the other. So when I go to graph it, notice I have a gap in my graph where there's no solution set. Everything to the left of 2, not including 2. Everything to the right of 1, not including 1. This interval to the left represents negative infinity to negative 2. Interval on the right represents 1 to infinity.